So this is an example of a little Lidar distance code I made. The Lidar is on a servo, and it's twisting back and forth and taking distance measurements. Here, for example, is the angle. I think it's 50 to 145. And I can put this here, and even though this sensor only reads distance, I can also check the angle that it's at and find the angle of the object. So if I move this to a higher angle, it's a higher angle, and a lower angle, it's a lower angle. I will make this better though. As I said, I'd make it better. So basically, what I'm doing here, here's my code, is I step into this while loop every 50 milliseconds, because that's the architecture I'm using. And then I have this reverse function. So it's a triangle wave generator, and the triangle wave represents the angle of the servo. So, and I can reverse the triangle wave at any time by flipping one bit, A. So basically, I am constantly checking to see if an object is inside my radius of interaction, which is about a meter. So it ignores everything else farther than a meter. And once something's inside that radius, it reverses direction. And then reverses direction again, and it constantly does that. And it actually gives you a plot of a very decent angle of where the thing is. So now, if I go up to it, see, here I am up at maybe 100, and I'll step down. And even lower. So it certainly isn't perfect, but it has a great range, and it's far better than the camera up here, because the camera only has 45 degrees field of view. It has to lock onto a QR code, which can go out of the field of view. This though, this can sweep anywhere, so I could set it all the way out here, and it'd still work. All right, better improvement now. Here's our angle. It only doesn't stop when it locks on, so it saves energy, it doesn't tweak out. But I can go over here. Now I'm quite low. No more jittering. And it doesn't find anything, it goes into scan mode. The way I did this one was basically, ooh, you gotta stop that waver. There you go. Where are we going? So here, basically, if it sees the target or not, and if it does see the target, it reverses direction and stops scanning. Lock goes to 1. Now, if it doesn't see the target, so the target's too far away, it steps to lock 0 and starts scanning again. It's pretty simple. And then the scan is built in bumpers and stuff. And I filter